So in this Algebra EOC review video, we're going to talk about slope. And most of the time when you hear the word slope, there's a few other words that may come to mind. You might think of a mountain, maybe. So on the EOC, they may use some other words that they are also using to describe slope. For example, steepness or elevation, a rate of change. I've got the symbols here, delta y over delta x, which means a change in y over a change in x, and also the word constant of variation. So they may use these words interchangeably, and it's all talking about the slope of a line. So when I think of slope, I always remember the words rise over run. And the letter M is always used for slope. So M equals rise over run. M also equals the formula y2 minus y1 over x2 minus x1. This formula is going to come in handy whenever we have two ordered pairs and we're trying to find the slope between those 2 points. Okay, so the two most important types of slopes are positive slopes and negative slopes. So a positive slope is going to go up and to the right, or you could say that it's going down and to the left. A negative slope goes down and to the right, or you could say up and to the left. In general, when I'm talking about slope, I say we go up or down first, and then always go to the right. If you run out of room and you don't have room to go down and right, then you can do the complete opposite, which would be up and left. Or if you don't have enough room to go up and right, then you could go down and left. You have to do the complete opposite of both. So first we're going to look on the right-hand side at these 4 different lines and find the slope between these lines. So the first one I have is the vertical line on the upper left-hand side. I'm going to put 2 points on the graph. Anywhere on the line is fine. And I want to count the spaces between those 2 points, and we're going to talk about rise over run. So this line goes up 7 spaces, but it doesn't go to the left or to the right. It's only rising, only falling. So for the slope, I would say that it's 7 over 0. It goes up 7, but it doesn't go to the right any spaces. When I try to divide 7 by 0, that gives me an error in my calculator, and we would say that that value is undefined. We cannot divide by 0. So one thing that helps me when I'm looking at a vertical line is I remember that the slope is always going to be undefined, and the equation of a vertical line is always going to be x equals some number. In this case, x equals -3. So the word vux helps me remember that a vertical line always has an undefined slope, and it's always an x equals equation. Okay, now we're going to look on the upper right-hand side. Again, I'm going to put 2 points somewhere on the line. This time it's important where I put those points. I'm going to put the first point on the y-intercept because it crosses at an intersection of the grid. And I'm going to find another point where it crosses at an intersection. And then I want to connect those 2 points using a triangle. So for this slope, this line, if I start on the left-hand side, is going down and to the right. So it's a negative slope. So the line goes down 5 spaces and right 6 spaces. So the slope, or m, is -5 over 6. If that fraction was able to simplify, then I would go ahead and simplify it. Now I can write the equation of a line. Y equals mx plus b. M is the slope, which we said is -5 over 6, and b is the y-intercept. So the equation of this line is -5 over 6x minus 2. Okay, now if I look at the line that is in the lower left-hand corner, this is a horizontal line. So I'm going to put 2 points somewhere on my line, and I want to draw a line to them, since I'm not going to be able to draw a triangle. Notice this line doesn't go up or down, it's only going left or right. So for the slope of this line, rise over run is going to be 0 over 6. It didn't go up or down, but it went over 6 spaces. So 0 divided by 6 is 0. Okay, what helps me for a horizontal line is I remember it always has a 0 slope And the equation is always going to be y equals some number, whatever the y equals. So if I count up, this line goes through y equals 5. So horizontal line, 0 slope, y equals a number. I remember the word hoi for a horizontal line. Okay, the last one in the lower right-hand corner, I'm going to put 2 points on the line again, this time at the y-intercept and another point where it crosses at an intersection. I'm going up and to the right to draw my triangle. So this is a positive slope. If I count my spaces going up, that's 4, and I count my spaces to the right, that is 6. So my slope, or m, is going to be 4 over 6, which reduces to 2 over 3. So I could write the equation of this line is 2/3 x plus 1. Has a slope of 2 over 3, and it crosses the y-axis at positive 1. Okay, now we're going to look on the other side of the page, and we are going to find the slope using the equation of a line, using a table, and using 2 ordered pairs. So when we're given the equation of a line, this is in standard form. It has x and y on the left-hand side. We want to try to get y by itself. When y is by itself, I know that the slope is the number in front of x. So first thing I'm going to do is move the 6x to the right-hand side. So if it's a positive 6x on the left-hand side, it's going to become a negative 6x on the right-hand side. So my new equation is negative 2y equals negative 6x plus 10. I still need to get y by itself, so I'm going to divide everything by negative 2. So y equals negative 6x divided by negative 2 plus 10 divided by negative 2. So when I simplify those fractions, y will equal 3x minus 5. Now what's important here is the slope. If we were going to graph it, it would be beneficial to know the y-intercept as well, but right now we're just talking about the slope of the line, which is the number in front of x. So m equals 3, or if I was going to graph the line, I would know to go up 3 and right 1. A whole number will always be over 1. Okay, now if I'm given a table, then I need to compare the change in values for the y and the change in values for the x. So if I look at the y's, I want to figure out how much are they going up or down each time, and it should be consistent for a linear function. So from 5 to 3.5, we're actually subtracting something. So you could do that on your calculator, 5 minus 3.5. So we are subtracting negative 1.5, or we're adding negative 1.5, either way that you want to think about it. And that's consistent as I go. I could keep subtracting negative 1.5, and that will give me all of those y values on the right-hand side. Okay, on the right-hand side, same thing. This one's a little easier to see that we're adding 1 to the x values each time. So when I want to look at the slope of the line, then I'm looking at the change in y's over the change in x's. So our y's were decreasing by 1.5, but our x's were adding 1. So if I do this in my calculator, negative 1.5 divided by 1, and I do math enter, it will change it back to a fraction for me, which is how I want my answer. So the slope of this line is actually negative 3 over 2. That means if I was to plot these points, I could see that it was going down 3 spaces and right 2 spaces every time. Okay, last we're going to look at finding the slope of the line given 2 ordered pairs. So we're going to use that slope formula from the very beginning. So m equals, and we wanted to label our 2 ordered pairs here. That will help you identify what goes where in the formula. So the first ordered pair, 6, 3, is going to be x1, y1, and my second ordered pair, negative 3, 0, is x2, y2. So the formula says y2 minus y1 over x2 minus x1. So for my values, that's going to be 0 minus 3 over negative 3 minus 6. So then I'm going to simplify the top and the bottom. When I do 0 minus 3, that's going to give me negative 3. And then negative 3 minus 6 will give me a negative 9. Then if I divide negative 3 by negative 9 in my calculator, and I do math enter to change it back to a fraction, then I'm going to get 1 over 3. That means this line is going up 1 space and right 3 spaces every time. So keep in mind for slope that we're talking about rise over run. It's a change in the y values over a change in the x values. I always say that we go up or down and then always go right when I'm plotting the slope. But you can use those other values too if you run out of room. Something else that's helpful is to remember VUX. A vertical line has undefined slope, and that's always x equals some number. HOI, a horizontal line, is always 0 slope and is always y equals a number.